And welcome back. And it's the 13th of Jan, 4 questions today. So let's get going. Okay, this first question not far off a sort of fairly normal GCSE question. Let's move this up a bit. So I'm going to do it 2 different ways, just so you've seen 2 methods. So method 1 is a bit of an algorithm. It will always work. It'll always give you the correct solution. So I do 2 times minus 10, so the A term times the C term, which is going to be minus 20. I then think about 2 numbers that multiply to make minus 20 and add to give me minus 1. And that's going to be minus 5 and 4. I'm then going to write this as 2x squared minus 5x plus 4x minus 10, which of course is exactly the same thing. I haven't changed anything. I've just split out the x into 2 different numbers. Then I'm going to factorise this bit here, which is going to give me, well, actually, all I can do is factorise out an x. So that's going to give 2x minus 5. Then I'm going to factorise this bit over here. Well, I can factorise out a 2, which is going to give me 2x minus 5. Correct that quickly. And so point is, as I just found out, unless this is equal to this, I have a problem. It is equal to each other, so it's okay. So I'm going to take out or factorize out a 2x minus 5, and that leaves behind an x plus 2. Not a terrible one, not too bad, and as I say, not far off a GCSE standard question really. The second way is what I'm going to call glorified guesswork. So it's, assuming it's a question in an exam, it's not going to be anything wacky like involve decimals or similar. It's probably going to be 2x and x, because these tend to be integers. So then I need to think about 2 numbers that multiply to make 10. Well, 10 isn't great because I've got 10, 5, 2 and 1 and some combination of those. So which combinations can I really get? Well, I want, definitely minus 5 seems like it's realistic. So minus 5, and if I sort of walk through why that's true, because I've got 1 times minus 5, and then I've got 2 times 2, which is going to give me 4. Now, in many ways, I didn't really help you know how to do that. It's just a bit of a feeling. You get better at it and you get more used to it. But I will say maybe a bit less with 10, because there's a couple of factors to 10. But the 2x and the x are pretty straightforward, and the other numbers kind of fall out. So sometimes it works better than others. The algorithm will always give you the right answer. Let's move on. Okay, next question. So this is, again, further maths, appears quite a lot in the non-calculator question. It's really just a Pythagoras question. Now, as I've said in other videos, let's not get clever about trying to make a fully accurate coordinate diagram triangle where everything's precise. It doesn't matter. All I need to know is that to get from the x value minus 5 to the x value minus 3, I need to add 2. In order to get from the y value 7 to the y value minus 6, that's a difference of 13. So in other words, although this looks nothing like a correctly scaled triangle, all I need to care about is the distance. The straight line in between is going to be 13 squared plus 2 squared, which is the same as 169 plus 4 square rooted, which is going to be the square root of 173. Now, it doesn't say in the question, but I would say to you that typically giving a rounded decimal answer is quite helpful as well. So that's 13.2 approximately, and give your accuracy to 1 decimal place. You'd get away with both of those because often the exams have something called or equivalent or anything which rounds to. So you should be okay either way with those questions. Okay, next question. The coefficient of x cubed in expansion of. Well, expansion questions are further maths GCSE only, and you'll learn a technique called Pascal's triangle, which again, you'll learn more of, and you'll learn combinations and other things later on. You're only expected to know Pascal's triangle. So you might just know what it is off by heart, and maybe you need to draw the triangle, but you'll get used to these numbers. The key numbers are 1, 4, 6, 4, 1. So I'm going to write those down. So 1, 4, 6, 4, 1. Again, Pascal's triangle, just adding the 2 numbers above. Then I'm going to multiply that by a decreasing x4. So x4, x3, x2, x1, x0. I'm going to multiply that by an increasing a. So a0, a1, a2, a3, and a4. Now, I've already gone quite too far because I didn't need to do any of this really, did I? Because all I need to care about which ones gives me the x cubed. So really, I could have just written this line out here. From the question, I know it's the case that 4 times x cubed times by a is equal to 256x cubed. Well, I don't really need the x cubes, do I? So let's ignore that. So therefore, a is equal to 256 over 4 which is equal to 64. Again, I do not need to write all these terms out. The quick way of doing this is to really think about which one of these I need. I need the x cubed. In this case, it's quite a straightforward question because I'm just expanding x plus a. It's not some complicated square roots or similar. But either way, answer for this one is 64. Well done if you got that. Okay, final question. Matrix multiplication. So again, you'll learn the basics of matrix multiplication. You only do 2 by 2 matrices in further maths, but nevertheless, it's a good skill to have because you can use it later on. B squared means you multiply b by b, as you should hopefully know. And if you don't, again, videos everywhere to watch this, but I'll walk through it quickly. You are going to multiply each row by each column. So in the top left number is row 1 times column 1. So minus 2 times minus 2 is 4. 5 times 4 is 20. Then bottom row and left column. So 4 times minus 2 is minus 8. And 1 times 4 is 4. Then top row times right column. So minus 2 times 5 is minus 10. And 5 times 1 is 5. And then bottom row times right column, 4 times 5 is 20, and 1 times 1 is 1. And let's collect all those numbers together, and that's going to give me 24 minus 5 minus 4 and 21. And that is the answer to the final question. As ever, well done if you've got all of these. Again, we're starting to mix up the questions quite nicely now. So we've had some matrix algebra, we've had some Pascal's triangle, a bit of a straightforward Pythagoras question, which is quite nice, and a bit of algebra at the start. Do leave a like to the video, just helps other people see it. Comments down below, gratefully accepted, and I will see you for the next video. Thanks all.